We have been talking about general principles and representations of instruments for last two lectures. Let's continue with lecture 3. So, in this lecture, we will introduce an important concept called functional elements of an instrument. We will try to see how these functional elements can be used to break down an instrument and analyze the functions of the entire instrument. We will also see how to classify various instruments. There are various considerations, and depending on those considerations, instruments can be classified in various manners. So, we will see some of those ways to classify various instrumentation. First, let us talk about functional elements of an instrument. All instruments contain various parts that perform specific functions in converting a variable quantity to a corresponding indication. Any instrument and its operation can be described in terms of such functional elements. So, the question we ask is how to identify these functional elements. Now, let us look at these various instruments. This is a ordinary mercury in glass temperature measuring instrument. This is another temperature measuring instrument, which is the thermocouple, and this is a pressure measuring instrument, and what you see is pointer and scale, and if you take out this dial, what most likely you will see inside is this, which is known as Boron tube. So, this basically is inside this, let us say. Now, the question we ask here is, there are various types of instruments. There are various temperature measuring instruments, there are various pressure measuring instruments, there are various flow level measuring instruments, so on and so forth. Now, if I look at these instruments with a view towards generalization, is it possible for us to identify certain elements in the instrument which does similar functions? So, I repeat, let us look at these various instruments with a view toward generalization. The question we ask is it possible to divide these instruments or break down these instruments into several components, and these components do similar functions when present in various instruments. So, if I look at this temperature measuring instrument and this temperature measuring instrument and this pressure measuring instrument. So, I have two temperature measuring instrument and I have one pressure measuring instrument. We should look at here in fact. Now, is there something common? Is there common elements in these instruments? Common in terms of functions that they perform, not by their look or appearance. For example, let us try to understand how we measure temperature using this mercury in glass thermometer. You must have measured temperature of your body using such a thermometer, or another mercury in glass thermometer perhaps you have used in your laboratory for measuring temperature of liquid. Now, what you do is you dip the bulb containing mercury to the medium whose temperature you are measuring. Suppose you are measuring the temperature of some water taken in a glass. So, I put the thermometer bulb into the medium, that means the glass of water. Now, what happens is the mercury receives thermal energy from the medium, undergoes restricted expansion. So, there will be expansion of volume of mercury, a pressure will be developed and the mercury will go up in the capillary and will finally rest at a point, and that point will be taken as a measure of temperature from the graduated scale attached to it. So, what was the first step? There was this bulb in the mercury which first interacted with the medium whose temperature I am measuring. Now, let us look at the thermocouple. Thermocouple is made of two junctions. So, we take two dissimilar metals and take two junctions out of it. One junction we call hot junction or measuring junction, another junction we call as cold junction or reference junction. Now, if these two junctions are kept at two different temperatures, an EMF will be produced, and that EMF is a measure of the temperature difference between these two junctions. Now, if one of the reference junction is kept at a constant temperature, then the EMF produced becomes a function of temperature at the measuring junction alone. So, to measure temperature by a thermocouple, what we do is we bring the medium in contact with the hot junction of the or measuring junction of the thermocouple. So, thermocouple receives the measuring junction of the thermocouple first receives information about the temperature of the medium. So, the mercury in the bulb in case of mercury thermometer and the measuring junction of the thermocouple are essentially doing similar function. So, they are functional elements. They may look different, but they are doing similar job. So, we call such elements as functional elements. Similarly, there will be a component in a pressure measuring instrument which will first interact with the medium whose pressure I am measuring, and again that will be the functional element for the pressure measuring instrument. So, in all instruments, whether it is a temperature measuring instrument or pressure measuring instruments or whatever, there will be a component which will first interact with the medium whose quantity is being measured, and that component will be known as primary sensing element. We will talk about Boron tube more later, but for the time being let us briefly talk about as follows. So, Boron tube is basically a metallic tube like this. So, you first take a tube with circular cross section, then flatten the tube to make the cross section elliptical, and then seal one end and then bend the tube with elliptical cross section in the form of a C. So, this end is sealed, this end is free, and this end is rigidly hold, and when pressure is applied inside this tube, this part is same as this. So, this part tries to regain its original circular cross section, and while doing so, there will be a movement of this tip of the Boron tube. So, this tip deflection is a measure of the pressure. So, once again I repeat, a Boron tube is as follows. You start with a tube with circular cross section, then flatten it diametrically so that the cross section becomes elliptic. Now, then you seal one end. Now, bend the tube which has now elliptic cross section in the form of a C. The free end you now hold it tightly and let the pressure be applied inside this Boron tube. Now, if we do this, the Boron tube will try to regain its original cross section, which is circular cross section. While doing so, there will be deflection of the tip of the Boron tube, and this tip deflection is a measure of the pressure that is being applied into it. Normally, a pointer and scale will be attached to the tip of the Boron tube using a gear and linkage system. So, the tip deflection can be read by the movement of the pointer against the scale, and that will be a measure of the pressure. So, now let us take an example. This is an example of pressure thermometer. You have a bulb here and then you have this dial here, and inside this dial we have either the C type Boron tube that we just talked about, or you have a spiral type Boron tube, which is very much similar to this in function, which is similar to the C type Boron tube. Now, this is connected by this one end of the spiral Boron tube, which is inside this, is connected to this bulb through this tube. Now, this can be schematically represented by this. We have this bulb, then we have this tube, which is this, and then tube is connected to this Boron tube. Now, with this Boron tube, you have a gear and linkage attached, and to that we have this pointer and scale. Now, how does it work? Inside the tube and the capillary and the Boron tube is entirely filled with some liquid or gas. The bulb you put into the medium whose temperature you are measuring. So, the liquid inside the bulb receives thermal energy, undergoes restricted expansion, a pressure is developed, that pressure is transmitted through this tube to the Boron tube. Now, this is same as pressure is being applied to the Boron tube. So, if pressure is applied to the Boron tube, we know there will be a deflection of the tip. So, this tip will deflect because of the application of the pressure. This tip deflection is magnified by this gear and linkage system, and we notice a deflection of the pointer against this scale. So, deflection of the pointer against this scale is a measure of the pressure that has been developed inside the Boron tube, and that pressure is linked to the temperature to which the bulb has been put, to temperature of the medium to which the bulb has been put. So, now let us try to see whether it is possible for us to break down this instrument into several functional elements. So, we just said that there will be a primary sensing element which will first receive information about the quantity being measured. Here we are measuring temperature. So, and the element that first receives information about the temperature is the bulb. So, the bulb is my primary sensing element. So, there will be a primary sensing element, and this element first interacts with the measured medium and first senses the quantity under measurement. Now, there will be some output of this primary sensing element. Here what happens is, the bulb is the primary sensing element, the bulb receives the thermal energy and then undergoes restricted expansion. So, pressure is developed. So, it may be necessary to modify the output of the primary sensing element to a physically different form which is more suitable for the purpose of measurement. That is the role of a variable conversion element. So, first element is primary sensing element, second is variable conversion element. Why variable conversion element is necessary? Because the output of the primary sensing element may be in a form which is not suitable for the purpose of measurement. So, we may have to convert it to a form, to a physically different form which is more suitable for the purpose of measurement. Note that information content must not be lost, but we are changing the variable nature because the other form may be more suitable for the purpose of measurement. In this example, the bulb is the primary sensing element, but the bulb also converts the temperature signal to a pressure signal, because it is within the bulb that the fluid undergoes restricted expansion and the pressure is developed. So, bulb serves the purpose of both primary sensing element as well as variable conversion element. Next, we may have something called variable manipulation element. Variable manipulation element, what it will do is, it will not change the physical nature of the signal, but it will either magnify or diminish the strength of the signal. Most likely it will be magnify the signal. It is like an electric amplifier. What it does is, the signal that it receives will simply be multiplied without changing the physical nature of the signal. So, the difference between variable conversion element and variable manipulation element is, the variable conversion element changes the nature of the signal, the variable manipulation element does not change the nature of the signal, it simply changes the magnitude, it simply amplifies it, or sometimes it diminishes it as appropriate for the purpose of the measurement. An example is the voltage amplifier. Then it may be necessary to transmit data from one point to another. For example, in the case of pressure thermometer, the variable conversion element and the primary sensing element both is played by the bulb. Then the pressure is developed, that pressure signal has to be transmitted to the Boron tube. So, the element that does this is the tube. So, the tube plays the role of data transmission element. So, the data transmission element transmits data from one point to another. In this example, the tube transmits the pressure. So, it is a data transmission element. You consider a spacecraft. The control signals are sent from the control station by using radio signals. So, that is a much more complicated data transmission element, and this is what I was talking about when I said that the functional elements does similar functions. They may be different in appearance, they may be different in the complexity of the operations involved, but ultimately they do similar functions. The tube is a data transmission element here, and the sending signal from control stations to spacecraft using radio signal is also a data transmission step, but both are completely different in terms of complexity involved, in terms of their appearance and so on and so forth, but in terms of functions they are same. So, both are data transmission element. We may have a data storage or data presentation element in the instrument. Data presentation element is the part of the instrument which presents data to the experimenter. See, the data will be presented in a form that appeals to any of the sense organs to the experimenter. Mostly we observe it, we view it, but we can see hear it also. See, a doctor's stethoscope. The doctor uses the stethoscope to measure your heartbeat. There it appeals to the audio sense of doctor. The doctor does not see it, the doctor hears it, but most likely we look at the temperature measuring instrument, we look at the temperature indicated by the instrument, or look at the pressure indicated by the instrument. So, the data presentation element will present data to the experimenter in a form so that we can understand it. Data storage element, as the name suggests, it can store the data like computer or any unit which has memory can store data. The data storage, usually data presentation element, let us drop this part from here and put a data presentation element like this, and this element can be named as data storage or data playback element. So, this stores data for future use which can be playback in future, such as computer and memory device. So, what we learned is that the following functional elements may be present in an instrument. First is primary sensing element, which first receives information about the medium which is being measured. Second, variable conversion element, which will convert the output of, say, primary sensing element to a physically different signal which is more appropriate for the purpose of the measurement. Next, we can have a variable manipulation element which will change the amplitude of the signal, which will not change the nature of the signal. Then we can have a data transmission element which will transmit data from one point to another. We may have a data storage or data playback element, and we will have a data presentation element. So, let us try to put these functional elements into a sequence, so that the job of the instrument or the function of the instrument can be explained. So, this is the process or the measured medium. So, some quantity about this process or measured medium I am interested to measure. So, primary sensing element first receives information from the measured medium. The measured quantity is also known as measurand. The output of the primary sensing element may go to variable conversion element. The output of the variable conversion element may go to variable manipulation element for changing the amplitude of the signal. The output of the variable manipulation element can go to data transmission element, so that the data is transmitted from one point to another. From data transmission element, it can go to data presentation element, or from the data transmission element, the data can go to a storage or playback device. The data transmission element presents data to the observer. So, this may be a logical sequence of the functional elements of an instrument, but in exact what sequence these functional elements will be present will depend on the particular instrument we are talking about. But if you understand the role of these functional elements, you will be able to analyze the function of any instrument in terms of these functional elements. Some points to remember about these functional elements. Functional elements are not physical elements, they are functional elements. We discussed one possible arrangement of functional elements. So, the exact sequence will depend on the particular instrument we are talking about. An instrument may involve the functional elements in any number and any combinations, like there may be two variable conversion element in an instrument, there may be two variable manipulation element, or there may be one variable manipulation element, or there may be none. It depends on the particular instrument that we are talking about. Instruments are in general not separated into such blocks. It is for our convenience we are separating the functions of instruments into such blocks of functional elements. A physical component may serve the role of several functional elements. We have seen this in case of pressure thermometer. The bulb serves the role of primary sensing element as well as variable conversion element. So, let us try to identify the functional elements of the pressure thermometer that we have talked about. First is bulb, is primary sensing element. It receives thermal energy, undergoes restricted expansion, a pressure is developed. So, temperature signal gets converted to pressure signal. So, it is also variable conversion element. So, bulb is both primary sensing element as well as variable conversion element. Then comes the capillary tube. It transmits the pressure from bulb to the Boron tube. So, the capillary tube is data transmission element. Boron tubes receive pressure as signal and gives output of the tip as gives output as the deflection of the tip. So, Boron tube changes the nature of the signal. Input was pressure, output is deflection of the tip or a motion. So, a pressure signal is get converted to a motion signal by the Boron tube. So, the Boron tube is variable conversion element. Now, this tip deflection, which is normally not great, small deflection, is magnified by this gear and linkage mechanism. So, this gear and linkage is variable manipulation element. So, motion is input to the gear and linkage mechanism, output is also motion, because output is the deflection of the pointer against the scale. So, gear and linkage mechanism is variable manipulation element. The pointer and the scale presents data by reflection of the pointer against the scale. So, this is data presentation element. So, variable conversion element, data presentation element, again variable conversion element, variable manipulation element and data presentation element. Sorry, this is data transmission element. Tube is data transmission element. So, if I just put these things into blocks, it will look like this. So, we are measuring the temperature of this fluid. So, fluid is my measured medium, temperature is measured quantity or measurand. Primary sensing element, variable conversion element, both are bulb. So, to bulb, temperature undergoes as input and what comes out from bulb is the pressure, because it plays the role of variable conversion element as well. So, the pressure is transmitted by the tube. So, data transmission element is tube. Then pressure is transmitted to the Boron tube. Boron tube receives pressure as input and gives tip deflection as output, which is a motion signal. So, Boron tube plays the role of variable conversion element. Then gear and linkage receives this motion as input, gives you motion as output, but magnified. So, gear and linkage serves the role of variable manipulation element. The output of the gear and linkage goes to pointer and scale, which presents data to the observer. So, pointer and scale serves the role of data presentation element. This way, if you understand the role of various functional elements in an instrument, you should be able to analyze any instrument in terms of its functional elements. In the next class, we will take another example and try to break down the instrument in terms of various functional elements that are present in the instrument. Remember, these are functional elements, not physical element, and there is no unique or there is no fixed sequence of the presence of these functional elements. The sequence in which these functional elements will appear will depend on the particular instrument. You have to analyze the instrument and then you will be able to find out the sequence of the functional elements that explains the function of the instrument as a whole. Thank you.